https://elimiconnect.github.io/elimu-connect-/elimu for CBC academic and coding lessons. Lesson 31 Key terms used in curved mirrors. Lesson content. Curved mirrors are spherical mirrors with a curved reflecting surface. Types of curved mirrors. Concave mirror, curved inward like a spoon. Converges light rays. Convex mirror, curved outward. Diverges light rays. Key terms. Pole P, the midpoint of the mirror's surface. Center of curvature, C, the center of the sphere from which the mirror is apart. Radius of curvature, a distance between the pole and center of curvature. Principal axis, a straight line passing through C and P. Principal focus, F, point on the principal axis where parallel rays either converge, concave, or appear to diverge from convex. Focal length, F, distance from the pole to the focus. For spherical mirrors, F equals R divided by 2. Question. Define the following terms as used in curved mirrors. A. Pole. B. Principal focus. C. Radius of curvature. Final answer. A. Pole, the center of the mirror's surface. B. Principal focus, the point where parallel rays meet or appear to diverge. C. Radius of curvature, distance from pole to the center of curvature. Lesson 32 Finding the focal length of a concave mirror. Lesson content. To find the focal length of a concave mirror, we can use a simple method involving a distant object, e.g. tree or building. Apparatus. Concave mirror, mirror holder, screen or paper, ruler. Steps. Set up the mirror facing a distant object. Hold a screen in front of the mirror and adjust its position. Move the screen until a sharp image is formed on it. Measure the distance between the mirror and the screen. This is the approximate focal length, f. Explanation. Distant objects produce nearly parallel light rays. These rays reflect and converge at the focal point of a concave mirror. Thus, the distance from the mirror to the image is the focal length. Formula for advanced learners. Using the mirror formula, 1/f equals 1/u plus 1/v, where u equals object distance, very large for distant objects. V equals image distance, is almost equal to f. Question. Describe how to determine the focal length of a concave mirror using a distant object. Final answer. Place a concave mirror facing a distant object. Adjust the screen until a sharp image forms. Measure the distance from mirror to screen, this is the focal length. Lesson 33 Image formation in curved mirrors. Lesson content. Concave mirrors form images based on object distance from the mirror. Ray diagrams. Use two principal rays. A ray parallel to the principal axis reflects through the focus, F. A ray through the center of curvature reflects back along the same path. Image characteristics at different positions. Object position, image position, nature of image. At infinity at focus, f real, inverted, very small. Beyond C, between C and far real, inverted, diminished. At cut creel, inverted, same size. Between C and F, beyond creel, inverted, magnified. At fat infinity, no image, rays parallel. Between F and P behind mirror virtual upright magnified. Convex mirrors. Always form. Virtual images. Upright. Diminished, smaller. Image appears behind the mirror. Uses of mirrors. Concave headlights, makeup/shaving mirrors, solar cookers. Convex vehicle side mirrors, security mirrors in shops. Question. State the type, nature, then position of the image formed by a concave mirror when A. Object is between C and F. B. The object is between F and P. Final answer. A. Image is beyond C, real, inverted, magnified. B. Image is behind the mirror, virtual, upright, magnified.